Clinton Wallace, director of the Space Weather Prediction Center. Can you hear me right now, Clinton?
Yes, I can. It's great to join you today.
There we go. It is good to have you on today. We're talking, obviously, we're just getting into our forecast and tracking Hurricane Gabrielle here that's in the tropics. But I want to talk about something that you have going on right now, because tomorrow NASA is going to be launching 3 new spacecrafts, I'm hearing, including something that will help when it comes to monitoring the weather as well. Talk to us about this project and what's going to be launching tomorrow.
Absolutely. So it's a different type of weather, space weather, not the hurricane, which looks like it'll stay safely out in the Atlantic, not affect our launch, but the space weather follow-on Lagrange 1 SWIFO L1 satellite will monitor space weather conditions in space 1 million miles from Earth. So if you think about that, that's about 4 times further than the moon is, and it's going to give us an unobstructed view of solar storms erupting from the sun.
You know, I have to ask this question because you just said space weather. I wonder how many people on average even understand that you can have what you would call space weather, because obviously when we think about it within our own elements. Can you break that down too?
Absolutely. So space weather deals with the emissions from the sun. So we're talking about solar flares and radiation and solar storms called geomagnetic storms or coronal mass ejections. These are billions of tons of plasma being shot out into space at millions of miles an hour. And when Earth's in the line of fire, it can affect our technologies here on Earth, such as the power grids, airline, GPS, and so much more.
So you were talking about that. Why is it important for us to be able to detect and be knowledgeable of all of those things? I think you just kind of hinted to it at the end there.
Absolutely. So, as I said, technologies such as the power grids, during these geomagnetic storms, these solar storms, the infrastructure on a power grid can be damaged. It actually can cause blackouts. Satellites in space, well, these solar storms can drag our satellites down, shorten their lifespans, as well as increase the collision risk. And then finally, like GPS gets disrupted during these solar storms. That affects our farmers planting crops or even our pilots navigating across the globe. And if we can give them early warnings of that, they can take measures to keep these impacts from having such big effects.
And I assume that kind of leads into, even the discussion for next year. I think the plan is to send astronauts to the moon with the Artemis program. And so this kind of goes hand in hand from what I'm hearing you in making sure all of that goes well and according to plan.
Absolutely. So Artemis 2, this is going to be our first moon mission, if you will. So it'll be orbiting the moon and coming back around. And we at the Space Weather Prediction Center within NOAA work very closely with our partners within NASA, both down at Mission Control or Space Radiation Analysis Group, as well as their Moon to Mars analysis office. And together, we keep our astronauts safe. And they're susceptible to especially radiation as you move outside of Earth's protective magnetic field, as you're showing here on the screen right now, that when we're inside that field, that protects us a great deal from radiation.
So out of curiosity, I want to know, because I know we just got maybe a minute more of your time, how far away exactly will these spacecrafts be sent in terms of the distance from the Earth, and how exactly do you go about choosing where they will be?
Well, this is a special point that in space that we're launching these 3 missions to. It's called Lagrange 1. It's basically where the equilibrium of the pull of the Earth and the pull of the sun, they balance. So if we think about it, again, 4 times further away than the moon. But let's put it in terms of football on a football field. If you were standing in one end zone on Earth, SWIFO L1 would be at the 1-yard line, and the sun would be way at the other end zone, 93 million miles away. So it kind of gives you a feel for the distances that we're talking about here at Lagrange 1, L1.
It certainly does. I think it also gives a great appreciation for science and the work that you all do as well, for the things that most everyday people are not thinking of, but we have you to be able to do so and make sure that we can stay safe, continue to explore and learn everything we can about this world that we all share. So Clinton Wallace, director of the Space Weather Prediction Center there at NOAA, thank you so much. We appreciate you for being a part of our stream this morning.
Oh, thank you so much for the opportunity to talk with you today.
Anytime. Appreciate you. So cool to hear from him and to hear about the project that they are working on ahead of the launch that they're going to have here tomorrow morning. And I believe that someone within the department was with us on Daybreak too, kind of breaking this up. And then Taylor, I'll bring you in and asking you, because you love science. Obviously, it's what you study. It's what you do. You are a scientist. And when we talk about all of the work that goes in, that we know from NOAA, from NASA, from all of our people who work in space and science, it really does also work in hand, though this project isn't necessarily what you do, but it all kind of works together, even with what you're doing when it comes to monitoring a forecast.
I mean, the sun is our biggest star, and it's the reason why we get hot and you get cold throughout the day. So studying the heliosphere, which is dealing with the sun, is really important. But also NASA launches satellites. They launch other things to help us with weather prediction as well. So we definitely work hand in hand with NASA. We work hand in hand with the National Hurricane Center. We work hand in hand with the National Weather Service. I like to tell people that broadcast meteorologists are kind of the liaison between the government entities and the general public. We kind of take everything that we know from our scientific terms, turn it into layman's terms, and then distribute that information to the public.
Okay, Miss Liaison.
Yeah.
I like to hear that for sure. I always love it when I get to talk science with Taylor, because she reminds me so much that I don't know.
It's okay. You're the writer. I'm the scientist. We go hand in hand. We all have very good qualities that work in conjunction. So.
I love it so much. Did you ever think about working for NASA?
I've had this maybe intrusive thought over the past year of maybe becoming an astronaut.
Oh, you just gonna stop it there?
Yeah, I'm just gonna stop it there because it's an intrusive thought. It's maybe not supposed to be in real life, but I've thought about, like, do I want to do that? But then I get scared because there's so much science that goes into literally rocket science. There's so much behind that, and it scares me, but it kind of intrigues me. So I don't know.